All right, everybody, let's hope this one works. Section 6-7, solving systems of linear inequalities. You're going to need a piece of graph paper and note page 88. So let's start out with a little vocabulary. System of linear inequalities is a set of two or more linear inequalities containing two or more variables. And we're really just going to be working generally with two linear inequalities with two variables, x and y. The solutions of a system of linear inequalities are all the ordered pairs that satisfy all the linear equations. So for us, it's usually both linear equations in the system. Get those two vocabulary terms written down there on page 88. Pause it if you need more time. Okay, first thing. Just like with linear equations, we can determine if an ordered pair is a solution, and so you don't need to write this down. You've done this so many times before, right? If you want to know if it's a solution to the system, plug the value in. If it's true, plug the ordered pair values into the other equation and see if it works for that one also. If both results are true statements, then yes, the ordered pair is a solution. If one of them is no, then no, the ordered pair is not a solution. So we're just going to do one of these together here. Jot it down somewhere there at the bottom of page 88. And let's give it a go. So the first equation, y is -3. And we plug in -1 for x, and we see what happens. -3 is less than 3 plus 1. -3 is less than 4. That's true. And since that one's true, we try it in the other one, and we get -3 is less than 2 times -1 plus 2. -3 is less than -2 plus 2. -3 is less than 0. That's also true, so yes. Right. -1 comma 3, -3 is a solution to this system of inequalities. Plug the values in, crunch it through. Same old, same old. Okay, so here we go. Don't need to write anything down from this. Just watch carefully for a moment. Okay. To show all the solutions of a system of linear inequalities, we have to graph the solutions of each inequality. There's no algebraic way to do this. Do you all hear me? There's no algebraic way to do this. You have to graph it. And then the solutions are shown where the shading overlaps. So here we have just two kind of random example graphs. Don't worry about what the equations are, just so you can see the idea of shading. So on the red dashed line here, the solutions for that are below the peach colored shading. And for the blue solid line, it's the light blue shading below the blue line. So the area where there are solutions is here, where I'm tracing in pink and going on forever out there, down further, where it is both blue and peach. So a good example of a solution would be their point there, 2, 1. On example 1b, the peach colored is above the red line. Look carefully, right? And the blue dashed line has blue shading below it. And so the overlap is this skinny spot in here. So that's where our solutions are. So at this point, 2, 0, that is not part of the solution to both inequalities because it's only part of one inequality's solution. So we're looking for the overlap. A better example of a solution would be like right here, which is at -2, -2. Okay, so I do want you to write down stuff from the next slide, which is the steps. Step 1, just somewhere down there at the bottom of the page, on page 88, solve each inequality for y, because you're graphing them, and that's the easiest way to graph them. Graph each inequality. Don't forget to put the right kind of line, dashed or solid. Dashed is for plain less than or plain greater than. Solid is for the equal to kind, just like open dots versus solid dots on number lines. And then shade the half plane of the solution, shading above for greater than or equal to, below for less than or equal to. And look for that overlap. The overlap is the solution of the system. There's no overlap, there's no solution. But that's only going to happen when lines are parallel. So don't worry about that quite yet. We'll get there though. You can show that overlap with either darker shading, multiple colors, or cross-hatching. That means lines going one way, and then the other way. That's cross-hatching. Let's give it a try. Grab your graph paper. Actually, well, I still would do this one on graph paper. This is the example, though, that is there in the middle of page 88. Okay, so there's our two equations. We're going to graph them, and it also asks us to give two ordered pairs that are solutions and two ordered pairs that are not solutions. It's a little bit different than the problem you have just in terms of what we give at the very end. Both equations are already solved for y. Hooray! Thank you, thank you. So we just start graphing. Okay. Go up 1. I'm going to do this one in pink, the first one. And slope of 2. Boom, boom, boom. Count off a few of them, just so we have enough places where we can shade. It is greater than or equal to, so that's a solid line. I'm going to do it freehand. It's better to use a straight edge, though. Okay. And then I'm going to graph my second line. I'm going to use a different color. Let's use blue. Oops, I forgot to shade below before. Hold on. Shading. I'm going to use pink. So the first one there, forgot to shade it, y is greater than. So I'm looking at values of y bigger than where I am. So above the line, look for bigger values of y. Okay. Fat highlighter shading. Right, now let's graph the other line. So y-intercept is -2, slope is -1/2. We don't need to worry so much about where the lines intersect this time, so don't panic if it doesn't seem like a good spot where they're crossing, because we don't really need that spot. Okay, and then we're going to use a dashed line. Once again, a ruler is a really good idea. This is not the world's straightest line. Arrow tips still. And it's asking us for greater than, so we're going to shade above the line again. And our solution is where they're overlapping. So for us in the overlap, watch where the highlighter is. It's up here, right, where it's both pinkish and bluish. These are the solutions. We could even go further out here because that blue line is going to extend. That's the answer. The answer is the graph. The answer is the overlapping spot on the graph. Please don't just show me the overlapping shading. I like to see where the single shading areas are too. So I like seeing each line shaded and the overlap. Don't be lazy. Now your little note page has another problem right next door, and I want you to go ahead and pause the video and do that one. Notice the lines are exactly the same, it's just the shading that's different. Well, and the type of lines is a little bit different. So pause it, do that one, and come back. Okay. Now that you're back, here is the solution for you to check. This time we shaded below the I think I changed the color. So I did the first line in blue, and I shaded below for that one. So that's over here in blue highlighter. And then over here. And then we shaded above the solid line for the pink one. So shaded up here. And I kind of outlined in green where that overlap is over here. This is all part of the solution. Let's do just one more of these. And on this one, we have to do a little bit of solving for y, so it makes it a little bit trickier. So let's get this first equation solved for y before we do anything else. Okay, so let's take this down here. So I'm going to add 3 x's to both sides. And I get 2y is greater than or equal to 3x plus 2. And divide everything by 2. There's no negatives, which is nice. And I get y is greater than 3/2 x plus 1. So let's graph that. Plus 1, rise 3, 1, 2, 3, run 2. And I'm counting by ones. Still easiest to count by ones unless there's some reason not to. Okay, and then we'll go back down here. And it's a solid line. And we're going to shade above the line because it's greater than or equal to. So there's my shading. Let's do the other line. Back to pen, back to, oh, let's go for red this time. All right, so we're going to do this one in red, and it goes through +3 and has a slope of 4. Rise 4, run 1. Steeper. And it is plane less than, so dashed line. Remember to pay attention to all those tricky little details and take little points off of tests. And this one asks us to shade below. So below the red line. Okay. And there's not a lot of overlap, but here it is, right in this part of the kind of the X of the lines in between. It's not a very big set of solutions. Oh, we forgot to list two ordered pairs that are solutions and are not solutions on the other ones. I forgot. Let's do it here. We won't go back and do all the other ones though. So two ordered pairs that are solutions. How about 1, 4? Okay, let's get a pen that'll show up. 1, 4, that's a solution. And how about 3, 7? That's a solution. Things that aren't solutions, there's so many of them. How about 0, 0? Not a solution. If you plug it in, it's going to be false. Right? How about -2, -2? So anything that's not in the, well, that's down here. That's still not a solution, but I was thinking -2, +2 before. Anything that won't make both equations true, anything that's not in the double shaded zone, those are not solutions. Okay? So it's just graphing the little bit extra from what we did yesterday. All right, let's keep going just a little bit more here. Okay. To talk about parallel lines. Okay. In lesson 6-4, we learned that for systems of linear equations, parallel lines never have any solution. But in systems of linear equalities, they can, depending on the areas shaded. So if you look at this example, don't write it down, just look. Right? Here we've got these two lines that are graphed. Y is less than or equal to -2x minus 4. That's the red line with the peach shading. And y is greater than -2x plus 5. The blue line, the blue shading. This is no solution, right? Because there is no overlap. But you can imagine that if things were different, that it could be shaded between the two only, or it could be shaded between and continue on to the blue. It could be shaded between and then continue on to the peach. So you have to graph them to be able to determine if they are no solution or whether there is some overlap. So we're going to do one together, maybe a second one, depending on how fast I talk here. I don't want the video to get too long. So 4x plus 6. So here's 5. Here's 6. Slope of 4. Right? And it's equal to, so we're going to just draw a nice line here. And we're going to shade above the line. So greater values of y. That's up here, so that's the top side of the line there. And now we're going to do the other line, blue, 4x minus 5. So here we are down here at -5. And still a slope of 4. They have to be parallel. And it is also equal to, so we can just draw our line. If your lines don't end up parallel, try again. And shade. And we're shading above the line also. So greater values of y. Our double shading is over here above the purple line. So these would be solutions, right, over here to the system of linear inequalities. Last one. Oop, I guess not. I thought there was one more in there. Oh, look, there was. It was hiding. I skipped it. So let's take a look at this one. 3x minus 2. You can pause the video and try it on your own if you think you're ready to be brave. I know you are. Now that you're back, you tried it on your own. You've got your dashed line here for the blue. Okay. And we're shading above that line in highlighter. This is my favorite part. And now let's do the other one in purple again. And we got plus 6. 1, 2, 3, 4, 5, 6. Should mark that on all of them. Okay, 6. And we know we have a slope of 3, because it has to be the same. And it is also a plain less than greater than line. So dash, 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 dash. Makes me think of Christmas carols. Dashing through the snow. All right, less than. And hello, let's get a highlighter. And purple, and less than now. So we're shading below the line to negative y values. And now the solution in between the two parallel lines. That's all we're going to squeeze into this set of notes. We will talk about a word problem in class, but for now, you're good to go.